Hey there, this is Seth Schaefer from Team Just Cause Robotics, and today's video will be about my newest robot design, a 1-pound Antweight bot called Mini Mulcher. Before we talk about my bot though, let's discuss the one that inspired it. I found out about the Mulcher when listening to blacksmith captain Al Kindle's interview on Behind the Bots a couple weeks ago. Here's what he said then.
There was also another bot called the Mulcher that they wouldn't even let start that not many people know about. It was like a lawnmower kicked up at a 45-degree angle. So they were, literally, it was a lawnmower, the bottom of a lawnmower built into this weird frame, and there's a video of that somewhere too. Doing a little demo and cutting up some foam. So it was a learning curve because again, the event runners didn't know what would show up, and you know, some people were a little ahead of the curve with dangerous stuff.
This is pretty much the only photo of the Mulcher that I could find existing online, and the original photo was 300 pixels wide. Yay 1995 cameras. So I've upscaled it about 8 times with a little bit of denoising, and it still looks kind of like crap, but you can get a much better idea of what's going on underneath that really bizarre looking frame from this photo, even though it's still like horrendously noisy and gives you almost no real detail of the lawnmower underneath. As you can probably tell, there were quite a few horrifying things about that bot. To be honest, I didn't look too hard and wasn't able to find that video until this morning, so I designed my entire robot without seeing that. I actually was mostly inspired just by the fact that it used an angled lawnmower blade as a weapon, since about a month ago I was asked if I might be able to use some lawnmower blades for a combat bot and was handed these babies. So my goal for Mini Mulcher is to accomplish 3 things. 1. Make an interesting Antweight robot. 2. Make it affordable and easy to make. And 3, create a detailed build video series so viewers can follow along. That way, you guys can potentially make this too, maybe as a second build or an intermediate level bot. It would be a bit too dangerous for a first-time builder, but I would say this should ultimately be a pretty simple build for anyone who kinda knows what they're doing. The budget for this bot itself is less than $250. It'll be manufacturable with just a 3D printer and basic tools like a handsaw or maybe bandsaw and a Dremel. If you already have wires, connectors, and other common components, you could be looking at well under $200. Last but not least, number 3, I want this to be my most detailed build progress series yet, so that viewers can learn everything they need from this video series to replicate basically everything I'm doing. I'll have a separate video for the modification of the servos, wiring and electronics, testing, any changes I make to the design will also be covered. I'm sure I'll need to tweak a few things here or there, since I still need to make some space for a power switch, but I can do that once I have them on hand to measure. I'll have the full robot CAD design on my store once it's ready. It'll be cheaper than Division's CAD model, since that was several months of work, and so far this bot's only been a week or so. Also, I can't find any lawnmower blades like these online, plus they need modification to be used anyhow to get the holes drilled for aligning them with the gear and whatnot. So instead I designed a 3/16" AR500 blade option that anyone can use, and that's already on my store for purchase for just $1. If you'd like, you can get this model exported as a DXF following a video tutorial I've already made and pinned to that store page. And you can send that model to Send Cut Send and they'll be able to cut you 3 blades for just $29. So for 30 bucks, you can get 3 of these 3/16" 9-inch diameter AR500 blades. I have the full bill of materials, subject to change, linked in the description. But I also have a blank template copy for my whole bill of materials that anyone could use for any of their future builds, because I found having one really invaluable to being organized. That way you can keep track of how much you're spending so you don't accidentally spend $2,000 that you don't have. And it also is really helpful if you just want to look up what the part number was for that screw that you used in another bot 3 months ago. Now back to talking about this robot. I weighed the 2 blades that I was given. The lightest one was 5.375 ounces or 0.34 pounds. Pretty heavy for an Antweight weapon, but I could make it work. Furthermore, since it's a 9-inch long blade, this bot would basically have just a gigantic blade for its size. I knew that a 45-degree angle on the blade like the actual Mulcher was out of the question. It would be way too unstable. 45 degrees would give me pretty much all of the limited turning mobility from gyroscopic forces that a vertical spinner has, and all of the limited general stability that a horizontal spinner has. So that was definitely not the way to go. I did, however, think that after looking around for different motors, I would need to angle the blade downwards at least slightly just to be able to hit at about 1-inch level or below. It turns out that angling only 5 degrees makes a pretty dramatic difference. This is only a 5-degree angle pictured here. So with this configuration, the robot's able to hit easily within 3/4 of an inch of the floor with these downwards angled blades. And I think that with the flat blade that I designed, it would still be hitting within 1 inch of the floor easily at the front. It's also hitting about 1.5 inches from the floor at the back, which for taller robots will still hit them for sure. I like to make sure that all of my bots have a bit of something different, so angling the blade for this bot is definitely one of those things. Directly driving the weapon with gears is another, but I think for Antweights that should generally be fine, because a lot of Antweight robots get away with driving the weapon directly on the motor shaft, which I was not prepared to do because I knew that that would be horribly poorly supported. This geometry with the 5-degree angle pretty much forced the rest of the robot to be pretty weird though. First of all, as you can probably tell, pretty much the entirety of the component layout is determined by the fact that I need the motor to be at the back so that it can be the tallest component, since the robot slopes forwards and gets, a lot shorter towards the front. I was pretty much forced to put the servo motors in the middle so that I would have wheels in the middle, and then I was forced to put the battery at the front because it was the shortest thing, so it was able to fit at the front, plus it can be best protected there. I'm designing this robot with a bunch of modular front-end attachments, so I'm basically going to be using these dovetails and then a bunch of stainless steel dowel pins to keep all the weapons in, or all the front attachments on. I should be able to push these out with just anything that's a smaller diameter into the chassis. I might have to take the lid off and pull the battery out to do so, but that way I don't have to mess around with like threading screws into plastic to hold on something that will be taking such tremendous shear loads. And I'm pretty sure that this should hold up just fine anyway. This is the heaviest front end attachment that I've designed so far with these hinged little forky wedgelet things. I designed them with this curve on the bottom just so I could tell which side is down, because I designed them to have basically an angle stop. So they pretty much have to stop going downwards at about that angle, which is a few degrees below the floor level, and they have to stop going upwards at about this angle, which should give them plenty of travel to deal with vertical spinners. I won't have the problem that a lot of forky bots have, where if their forks are like this, that they push their wheels off the ground and they can get stuck like this. I don't think that there's any way that the bot will get stuck with the forks at just this shallow of an angle. It took me a while just to find a motor that I could use that would be ideal for this. So if I hide the lid here, you can get a better look. I can also hide the whole weapon setup actually. This is what the inside of the bot looks like without the polycarb panel in the way. I may or may not actually make that top panel out of polycarb. I just thought that would be ideal, but it could definitely be 3D printed for just ease of access of that if you don't feel like, cutting a circle out with a hand saw if you don't have access to a bandsaw or something like that, or a CNC router, which I'll probably end up using if I do go with polycarb. So this motor here is pretty much the most powerful short form factor motor that I could find. And I spent a while trying to find a motor that I thought would be suitable enough, like more than 100 watts of power running on 3 or 4S, and then also just like physically as short as possible. Most of the 2212 motors that I see a lot of like Antweights and Beetleweights using, just because they're like super dirt cheap, they have a 12mm tall stator, which means that the entire motor is more like 24 or 25 millimeters tall. Or I'm sorry, not 24 or 25, like 45-ish millimeters tall. This motor is about 0.6 inches tall, which is like nothing. That's only about 26 millimeters, I believe. So that allowed me to basically shove it to the back so that it's at the tallest portion of the chassis. And then I basically just figured out exactly where the gear needs to be, lop the top of the shaft off the motor to make it as short as possible overall, and then determined precisely how much room I'd need around it for everything else, and that pretty much made all the rest of the components more or less fall into place. I decided that I wanted to use these servo motors for drive, because A, they cost less than $5 a piece, and B, you can get Metal Gear versions of them that are still $5 a piece but can be modified for continuous rotation. Though you can also buy like standard RC airplane type, like 9-gram continuous rotation servos already with the ability to act essentially like a motor plus ESC combo without needing a separate ESC. So the nice thing about these is that when you hack them for continuous rotation, instead of just going to a set angle like a normal servo does, the board that's making it go to a certain angle is just doing that based on a positional feedback from a potentiometer. So all you really need to do is remove a mechanical angle limit and then disconnect the potentiometer at the center position. And then when you tell it to turn one way, it will just go that way forever. And proportionally to how far you push the stick, it will change its speed. So it essentially acts exactly like an ESC would. And you don't need to have a separate ESC. It's just built into the controller board inside these. I believe that they also frequently have some sort of current limiting built in so that they won't like burn out. So it's pretty nice to have something like that in a compact package. The downside to them is that they have a ton of torque, but very low speed. I think that it's rated at like 0.8 seconds to rotate like 60 degrees, which equates to somewhere in the realm of 100 RPM. That's really, really slow, especially with wheels that are effectively a 3/4 inch diameter, which is what I'm using here. The wheels, by the way, are going to be 3D printed like everything else, and I'm going to be using O-rings for tires just like I did on Draconid because that seemed to work very well. So these are going to be 1.5 millimeter diameter O-rings, 3 of them per wheel, and then I'm going to try my best to 3D print this servo spline, but I expect that to go very poorly, so I'm probably going to mostly rely on a combination of gluing them on and then using the I think M2 screw that comes with the servos to screw their like attachment arms onto, to just screw the wheel onto that. And given how little weight will be on each wheel, like half a pound, I don't think that that'll be coming loose anytime soon. Plus, I mean, this robot has protected wheels, so they're not likely to take any direct hits. Everything that I want to 3D print for this robot, I'm going to be printing out of nylon, but it would probably work just as well in PETG if your printer can't reach the temperatures required for nylon. And you can see that I made generous use of fillets where needed to basically strengthen up all of the what otherwise would be sharp corners and stuff. I have the servos kind of just like sitting in a pocket right now, but what I think I might do is add a separate 3D printed part that's like a little shelf that connects across these points, and then I could add a screw here to just hold it down. Or I might just put some foam on these and then compress it down with the lid, just like I do to hold the batteries in Division and Draconid, because that seems to work pretty well for them. And like, there's no way the servo can rise high enough with the lid on to come out of those slots anyway. I just don't necessarily want it to have the extra little bit of wiggle room that it will have. So this robot's very light on screws, which is one of the nice benefits for a 3D printed bot, is that you can use a very small number of screws. So there's 6 on the top here, 2 more here, and then just 4 holding the motor in, and then 2 in each of the wheels. And that's literally like all of the screws that I'll need probably for the entire robot, which is pretty nuts. These are all plastite screws around the periphery here, and then I already have some 632s from Division, and I already have these plastite screws from Division. These are number 6-19s, and then these are the 632s that are just standard number 6 screws. Will thread into the plastic well enough here, because really these screws are just to prevent the top plate from being able to like flex upward, or just basically keep it as flat as possible so that it can't get like bumped into the path of the weapon or anything crazy like that. There's no real like super big reason to have these extra 2 screws here, but it doesn't really hurt. So you might be wondering what the hell this is. This is just a standard shoulder bolt, because that worked really, really well for Division's weapon axle. So it's going to be a dead shaft. And the deal with this is I wanted to basically just thread it into the plastic. So the thread on this is a 1/4 inch shoulder diameter, which is the same that I used for Draconid's drive axles. So these are pretty strong. They're solid hardened steel. They're ground, so that they're specifically meant to be used with bearings. I'll be using the same bearings that I used on Draconid's wheels in the weapon stack up. So basically, I've got my 1/4 inch ID, 5/8 inch OD, I think they're like 0.196 thick bearings. Those are the standard size for a 1/4 inch ID bearing. I've got one on top, and then there's one underneath that you can't really see because there's a spacer in the way. And then there's a little bit gap in between them just because that's how the height stack up, kind of lined up. You can see the weapon's kind of like shy of the top surface of this bearing, which is kind of intentional because when you put the one that I designed for other people to use on here, it's like twice as thick, so it sticks out actually a bit proud of here. And it doesn't really make a difference either way because as long as the bearing is like not able to like fly all over the place, it'll be fine. So I'm just going to activate a section view here and you'll get a much better idea of how exactly this is held together. So this is basically a section view cutting the entire robot in half down the middle from front to back. And as you can see, I've essentially just modeled in printed threads, but like an entire 3/8 inch section of printed threads into the chassis and a stop to those threads and a shoulder where the bolt needs to bottom out. So the idea here is that this is a 1024 coarse threaded screw. So if printed threads are going to work for anything, they'll work for this. And I've had them work successfully for a much finer thread screw in the past, so I don't think this will really be a problem. I'm going to make sure that it bottoms out here, and that'll kind of like set the height for everything. But if it needs to be moved out a tiny bit, I can just kind of compress these bearings against this spacer and then change the exact height of the spacer, maybe even just by filing it down to make it the exact right height that it needs to be. And then you can also see this gear on the weapon axle is way thicker than it is on the motor axle because, let's see if I can get across so I can screw it there. It's way thicker than it is on the motor axle. That's to give me the ability to get some of that height misalignment, but also to make it so that if this weapon flexes after being hit a bit, it won't just like hit this gear and like lop it off immediately from the tiniest bit of movement. So I think there should be sufficient clearance here, but I could always just make this spacer thicker and raise the whole thing by the difference between this point and this point, and then I would definitely have enough clearance. One thing that kind of concerns me a little bit about my design here, though, is this gear has relatively little meat to it, especially where like the corners of the material are at the teeth. But there's not really any way around that. And I think that it isn't going to be a huge deal because there's no reason that it would really fail because it's just going to be compressed into the steel there. And there is a decent amount of meat here at the bottom for the thickness where it's just plastic on the central axle. So the axle of the motor is, I think, a 5mm, yeah, it's 5mm axle up to an M5 thread, which should be only a clockwise thread because a lot of drone motors come in pairs. You'll get like 4 of them at once, and 2 of them will have a counterclockwise thread, 2 of them will have a clockwise thread for mounting propellers that spin in opposite directions. That would be a problem. But I'm pretty certain that I should be able to use just a standard off-the-shelf M5 lock nut to hold this gear on, and that's going to be compressing this spacer, which is again 3D printed to set the height of this gear, which then compresses directly onto the motor shaft because this is an outrunner, so the entire shaft turns. So this gear doesn't need to be turning separately from the shaft or anything. So then in the weapon side, I am going to do something similar to what I did with the Vision, using a 3D printed gear to drive the weapon, but this time I'm threading into the steel weapon instead of threading into the gear. And I can make a different version of this that has the screw higher up, or you could just use longer screws than I'm using here when you're using the thicker weapon. If you're going to make this bot at home, I would probably just recommend using larger screws because I already countersunk this like way more than you would need to otherwise. You just need the screw heads to basically not be below the bottom surface of the gear, and then you're fine. And as you can see also, I intentionally have bearing proud at the bottom, and also you can see the spacer is tapered because it's kind of not great to have both the outer and inner race of a bearing resting on a spacer. You really only want the inner race touching if you can avoid it, because the outer race is what's actually going to be turning. The inner race can be stationary and it doesn't matter. So having the spacer contact only the inner race, which is going to be stationary, just does a little bit extra to reduce the amount of friction. And you can see it kind of already works out that that'll happen on top with the shoulder bolt only contacting the inner race of the bearings to begin with. And yeah, I have this tiny receiver in here. This is a receiver that's compatible with the transmitter I've been using already, and it's, I think, called like the FS2A or something. So it works with any FlySky radio, I believe. It definitely works with the FSI-6. It specifically advertises itself as being compatible with the FSI-6. And it's only a 4-channel receiver. I have already had these, I already known about these because Team Panic did a video about them like a while back, and thought that they were the best thing to use in Antweights, but he's in Australia. I think he may have been doing 150 gram Antweights, so if they work for a 150 gram Antweight, they'll definitely work for a 1 pound US Antweight, which is way heavier. And it's just a way smaller package. There's like no way I could have fit the receiver that I put in Division, the like standard FSI-6 IA6B, I think it is, receiver. There's no way that that would fit in this chassis. It's just way too small. And this is already up on its side, and it's, you know, only a tiny bit shorter than the battery, so it like barely fits in here to begin with. I really didn't need to deal with like decasing and like trying to like cover and hot glue the other receiver and then like figure out how to bend the wires in. So the nice thing about this is that I didn't CAD it in detail because there wasn't really a need to, but the wires plug in from the side here, not from the top out here. So I can actually like fit it in this crevice and then still actually access it with wires. And then the antenna is out the back here. I should be able to just wrap it around here. I might like make a channel that it goes into or something, or I might just cut it short because honestly I don't think it's particularly necessary unless I'm trying to control the bot from like hundreds of feet away. This is the speed controller I modeled in. I'm not 100% sure which exact version I want to use yet. I wanted to use the 35 amp BL Heli ESCs, but they don't have a BEC built in, so I need a separate BEC. And with weight at somewhat of a premium and space definitely at a premium, that might not be the best option when you can buy really cheap, not programmable, like 30 amp or 20 amp ESCs off Amazon that have a BEC built in. But I think for now, I'm going to try and find space for the BEC probably around here and just try and use this. So my wiring would basically be battery wires come out and wrap around here to the BEC and to the ESC, both in this area. The motor wires would just have to be coming either if there's space this way and around, or if there's not, that way and around. And I've had like a little cutout here in case the wires need to come out that way. So I think it'll be fine to have them just go backwards or forwards if there's enough room for them to bend around, and then just get connected to the ESC that way. And I'll probably try and fit some bullet connectors in, but they'll have to be like in here somewhere and take up as little space as possible. And then on the receiver side, the BEC will have wires that go to it. And then the servo wires unfortunately come out on this side, so they'll also need to be routed through these little channels and then just plug into it there. So cable management is going to be kind of a nightmare in here, but such is life when you're designing a hockey puck chassis with you know, a 5-degree angle sliced out of it. So yeah, I think that pretty much covers all of the electronics that I'm using and like how I'm planning on routing wires to connect everything up. Like I said, I don't have the BEC CAD'd in here, but right now with this heaviest front attachment, I have about ½ an ounce to play with, so that should be plenty for the wiring and everything. I'll also, you can see in the bill of materials the LiPo that I'm planning to use. It has a fairly weird shape to it. This LiPo on the Amazon listing has 2 different varieties. There's one that's like this long skinny pack, which is what I'm using, both because A, it fits in this shape a bit better, B, it's a little bit shorter overall, and C, it is actually a bit lighter than the alternative, which is more of like the typical, like more like almost this length, and the overall length are like maybe like a 2-to-1 ratio, as opposed to here where it's like a 4-to-1, like way longer than it is wide. And then the wires coming out this side is kind of annoying, and I'm not sure how flexible those will be, but I'm betting that I'll be able to bend them tightly enough to get in here. I might need to add some sort of foam spacer or something in here. I definitely don't want these dowel pins to be like punching directly into the LiPo or anything, but that should be pretty easy to avoid without any catastrophic failures or whatever. So yeah, that pretty much covers everything with Mini Mulcher. Hope that you guys subscribe, stay tuned for more, and Make sure to check out the store page if you'd like to support these videos. I don't have a set timeline for this build series, but it'll be mixed in with a bunch of Battlebots related content as well over the next couple months, so make sure to stay tuned for all of that. Thanks for watching!